Very good morning. Today we have Lambda iteration method. This is the one type of algorithm. We are having set of rules to solve the economic load dispatch problem. It is not very new to us. This type of Lambda iteration method is not very new to us. Already we have seen. So the same thing, what we are going to do is we are seeing the same thing in the set of rules. That is, with the certain steps, we are going to see the same we have seen by using this algorithm. That's all. So in this Lambda iteration method, so there are some 7 steps for solving this so instead of going for some equation differentiation like that, directly what we are going to do is directly we are substituting in the formula and directly we are going to solve the problem. No need of going for differentiation, then equating it to lambda, again finding out lambda like that. So directly we are going to find out the lambda directly, PG1, PG2, PG3 like that. Why? Because this problem, if you turn your pages to the previous problem. In the previous problem, so everything is very lengthy. Okay, so first we need to differentiate, again we need to equate it to lambda, again we need to equate it to demand, then solving some 3 equations, again you have to find out lambda, then again you have to note down the PG1, PG2, PG3, then in the meanwhile you have to note down the limits, our operating limits. So everything we need to find out. The steps are very lengthy, right? If you take those problems, and if you see that the steps and the methods are very lengthy to solve and also very time consuming. So now we are going to see the same thing by using the substitution formula. Like that, what we are doing is we are going to find out the certain steps are there. With that steps, we can easily find out the lambda, PG1, PG2, then some like operating limits, everything. With that, we are going to find out. So first, what is the step number 1? Step number 1 is assign the initial values of lambda. Assign the initial values of lambda using the following equation. So this method, if the operating limits of the power generation are not specified, this method is used. So first we need to find out what is lambda. Assign, because step number 1 is assign the initial value of lambda. So no need to memorize what is lambda like that. The thing is that we know the general formulation, fuel cost function. From that we are going to find out lambda. No need to memorize the formula for lambda. So if you just remember that thing, that is well and good, or otherwise also no need to worry about that. So in this subject is concerned, this subject is concerned, as I said before, the formulation is very easy. No need to memorize even a single term, single equation like that I said. So you just have to frame and you need to derive for the answer. That's all. But this is the algorithm. I'll tell you the how to find out the lambda. Then after that, whether you can remember or not, that is your wish. Or otherwise, if you are unable to remember, also no problem. You can easily calculate that. Okay. So you need to you need to go back to our first to second classes, and we need to calculate the lambda. Okay. So what we derived, the fuel cost function, what we derived, the fuel cost function is Fi of PI is equal to AI PGI squared plus BI PGI plus CA. So this is the general formulation. Either we can use PGI also same, PI also same. Okay, power generation of the ith generating unit, that also same. Some other notation they are using PGI also. Some other notation PI also they might be used. All are same one. Okay, so this is the fuel cost function. So what we need to do is we are differentiating and equate it to lambda. So if you differentiate, like dfi divided by dpi is equal to 2 into ai pgi plus bi. So this term will become 1. So constant is constant only. So that is equal to lambda. So from this we can easily find out pgi. From this we can easily find out pgi. So pgi, what is pgi? Pgi is equal to lambda minus, so this term we are taking outside, so lambda minus bi divided by 2ai. Okay, because this is multiplied with pgi. So if it is comes here, so if we need only pgi, so we can take like pgi is equal to lambda minus bi divided by 2ai. So if you remember this equation also, no problem. If you don't remember also, it is very just yeah, 1 minute job to just you can derive and you can calculate. So PGI is equal to lambda minus BI divided by 2AI. So in this, losses are neglected. Okay, so what is the power balance equation? Generally, power balance equation is nothing but generation is equal to demand plus losses or load plus losses. So here losses is neglected. Only we are taking only economic load dispatch without the losses. So if you take like summation I is equal to 1 to n PG, that is PGI is equal to PD. PD or P load. Okay, so this is the general power balance equation. So already we calculated now PGI, we already calculated. So that PGI you need to substitute over here. Okay, that PGI you need to substitute over here. So if you substitute PGI, so we already calculated now. So what is the PGI? Yeah, PGI is equal to lambda. Yeah, PGI is equal to lambda minus BI divided by 2AI. So just like that, we are substituting and equating it to PD. So we, while substituting, so it will come like this. So like summation I is equal to 1 to n lambda minus BI divided by 2AI. That equals the PD. So now we have to find out the lambda from here. So for finding out the lambda, what we need to do is we need to segregate the lambda. So I'm taking this lambda outside. So summation I is equal to 1 to n 1 divided by 2ai minus summation I is equal to 1 to n bi divided by 2ai, that equals the PD. So next, taking only lambda, we need to find out lambda because step number 1 is finding out the lambda. Okay, assign the initial values of the lambda. So from this, how to find out the lambda? So you have to take this term outside and this term to downside. So you can easily find out lambda, that is PD plus. So here it is minus. So if you this term, that is BI divided by 2A, goes to the this right hand side of the equal to sign, so it becomes plus. So divided by, so here summation 1 I is equal to 1 to n 1 divided by 2a. So easily you can find out the lambda. So lambda is equal to PD, that is demand, PD plus summation I is equal to 1 to n bi divided by 2ai. Okay, the whole divided by summation I is equal to 1 to n 1 divided by 2ai, the whole divided by. Okay, so sometimes what they will the mistakes, major mistake the students will do is instead of taking whole divided by, they will just divide. So these two terms alone they will divide and they will add with the PD. Okay, in that scenario the answer will come wrong and the demand might be not satisfying, and your generation will be having different data, sometimes negative and more, and like that also sometimes it may come. So this is whole divided by. Okay, if you forgot this, if you just forgot this formula, that is lambda, how to find out lambda also, you can simply derive just 2 steps only, just a substitution only. Already we know this. Okay, so you substitute and you can easily find out this value. No need to memorize this. This lambda is equal to PD plus summation I is equal to 1 to n. bi divided by 2ai, the whole divided by summation I is equal to 1 to n, 1 divided by 2ai, like that. So no need to memorize these terms. Simply like that, you can derive and also you can take. And if you well and good. Okay. So here, what is the step number 1? Step number 1 is assign the initial values of lambda using this formula. So what is this formula? Plus summation I is equal to 1 to n, bi divided by 2a, the whole divided by summation I is equal to 1 to n, 1 divided by 2ai. Next, step number 2. Step number 2 is compute the PGI. Compute the PGI using the formula. So what is the PGI? We already calculated here itself. We already calculated here itself. That is PGI is equal to lambda minus bi divided by 2ai. Lambda minus bi, the whole divided by 2ai. So while doing this also you have to very careful. All are whole divided by only. Okay. So if you take like bi only divided by 2ai, and if you find out this answer again, if you minus with the lambda, then the answer goes wrong. PGI goes wrong. It will come more than the demand. Like that, some other values will come. So you have to very careful here. PGI is equal to lambda minus bi, the whole divided by 2ai. If you forgot this also, just derive only one step. Derive and find out this. Okay. So step number 2 is to compute the PGI using this formula. That is PGI is equal to lambda minus bi divided by 2ai. Next, sorry, yeah. So step number, what is the step number 1? Assign the initial values of lambda. Lambda we already calculated. Next is step number 2 is compute PGI. PGI, what is the formula for PGI? PGI is equal to lambda minus bi divided by the whole divided by 2ai. What is the step number 3? Check whether the computed power is within the operating limits, minimum and maximum operating limits or not. That is PGI minimum less than or equal to PGI less than or equal to PGI maximum. Okay, so the computed power, whatever the values we found out, what we are doing is we are checking. Say similarly like what we did like in the previous problems. Similarly, what we are doing is we are checking whether the computed power is within the operating limits of that. So that is PGI minimum less than or equal to PGI less than or equal to PGI maximum. So whatever the values, say for example PGI you found finding it as 1000 megawatt, PG2 sorry PG1 you are finding it as 1000 megawatt, PG2 some 1500 megawatt. So whatever the values it is coming, that is should be within the minimum and maximum operating limits to that particular, say for example installed capacity of the particular stage 1 of the thermal generating unit itself 1500 megawatt. You should not decrease the generation to 1000 megawatt. So what is the limit? Generally some limit might be given for that particular stage 1 or 2 like that. So what is the, say for example stage 1 minimum and maximum operating limits is 1000 megawatt to 1500 megawatt. So you should operate that generator within this limits only. Either you can generate 1000 megawatt or 1100, 1200, 300, 400, 1500. Up to 1500 you can generate. You should not go beyond that value. If you go beyond that value, you know what are the limitations that we already discussed. If you are finding doubts, you go to the previous classes and see what happens if we go beyond that limits. So what is the yeah? So if this condition satisfy, if this condition satisfy, if it is within the minimum and maximum operating limits, then optimum solution is obtained. Optimum solution is obtained. Otherwise, go to the next step. Otherwise, go to the next step. That is step number 4. What is the step number 4? If PGI, whatever the values we found out, PGI violates the operating limits, then fix the generation at the respective limits. If PGI violates the operating limits, then fix the generation to its respective limits. That is, if PGI is less than PGI minimum, then PGI is equal to PGI minimum. Okay, like one problem we have seen in the so if like that PGI value, say for example that PGI value is not satisfied, but it is violating its minimum operating limits. Now fix the value to its minimum operating limits. If PGI value, okay, violates its maximum operating limits, now you fix the value to its maximum operating limits. That's what this step is. That's what this step is. We solved one problem. For better understanding only, I solved that problem previously only. Why? Because you can find the complexity, like so what we did without this algorithm, what we did after this algorithm, how shortly we are going to finding out the answer. That's why I solved the problem previously itself, just to know how complexity if you solve without the algorithm or with the algorithm. Like you need to differentiate which is best, with the algorithm or without the algorithm. Like after knowing this algorithm and after solving the problem, you can easily tell like which one is best to solve the problem. Next, so this is the limits. So if PGI is less than PGI minimum, then fix the PGI is equal to PGI minimum. If PGI is greater than PGI maximum, then fix the PGI to its PGI maximum. Next, step number 5. Step number 5. So what is the step number 5? Redistribute the remaining system load. Redistribute the remaining system load PD. So you need to find out why, because now the limits got violated. Now the limits got violated. Okay, so with that violated thing, we need to find out the new demand. Okay, so because it is violates upper operating limits, and if it is violates lower operating limits, we are fixing now, and we are fixing so that we need to find out the new demand. That is by using this formula. So PD new, demand new is equal to PD old, demand old, minus sum of fixed generation not satisfying the operating limits. Say for example, I am telling you how to find out the PD new, in the sense, say for example, 2 generating units, like we solved in the previous problem. 2 generating units not satisfying the minimum and operating maximum operating limits. So what we did in that case is, so I think 1 generating unit, like P1 generating unit violates its upper operating limits or maximum operating limits. So what we did is we fixed that value to its, I think 300 megawatt, for example, I'm telling. So we fixed that generation unit 1 to its like maximum operating limits, that is 300 megawatt. And another one in that same problem, the third generating units not satisfied the operating limits. I think third generating units, it's not violating its minimum operating limits. So what we did is we fixed that value to its minimum operating limits. I think 50 megawatt we fixed. So in this case, what you need to do is you need to sum of the fixed generation not satisfying the optimality limits. So that 2 generating unit only not satisfies the optimality limit. So what we are going to do is we are fixing the generation. We fixed the generation. That fixed generation we are going to sum up. Say for example, P1 we fix it to 300 megawatt. P3 we fix it to 50 megawatt. So now what we are doing is we have to sum, that is 300 plus 50, 350 megawatt. Say for example, here you need to take 350 megawatt. What is the PD volt? Say for example, sometimes in the problem they have given like PD volt value as 1000 megawatt. I'm telling you one example only. 1000 megawatt they are selling. So sum of the fixed generation like 300 plus 50, that is 350 megawatt. So 1000 minus 350 megawatt. So what is the value? That like 650 megawatt. So that is the new demand. So like that you need to right over here. Okay, so PD new is equal to that 650 megawatt. Like that, you need to proceed the steps. So next, what is the next step? What is the step number 6? Step number 6 is compute new lambda, that is lambda new and PD new, and compute the remaining generation using the equation. So you need to compute new lambda here. So new lambda, what is the formula? Same formula only. So lambda new is equal to, okay, lambda new is equal to PD new. So here also what we are taking is PD new plus summation I is equal to 1 to n bi divided by 2a, the whole divided by summation I is equal to 1 to n 1 divided by 2a I. So this is the lambda new value. Again we'll discuss the whole thing. Next, again compute the remaining generation using this equation. So from this lambda new value, so whatever the lambda new value we got now, from this new lambda value, we need to find out PGI. Okay, PGI new. Okay, so PGI new is equal to lambda new minus BI. So sorry, there is a mistake. BI divided by 2a, small bi divided by 2a I. Okay, so this is the step number 6. Next, step number 7 is check whether the optimality condition is satisfied or not. Check whether the optimality condition is satisfied or not. That is, say for example, dfi divided by dpi is equal to lambda nu for PGI minimum less than or equal to PGI less than or equal to PGI maximum. If dfi divided by dpi is less than or equal to lambda for PGI is equal to PGI maximum. This optimality condition we already seen, is not new to us. Okay, like this we have to check the optimality condition also. Next step, if this condition is satisfied, if this optimality condition also satisfied, next step, stop the procedure. Otherwise release the generation schedule. Fixed at PGI minimum or PGI maximum of those units not satisfying the optimality condition. Say for example, if this condition also not satisfied, again you need to go to the step number 3. Again you need to fix the generation, that is PGI minimum or PGI maximum. So again you have to proceed the same steps. Again you need to calculate the PD new, again lambda new. Okay, again you need to check the optimality condition. Like that you need to repeat. If this condition also not, if that condition satisfies, stop the procedure. That's what here it is. If that condition satisfied, stop the procedure and end the program. Otherwise, again what we need to do is, again we need to fix the generation. Again we need to fix the generation to its minimum or maximum operating limits. Again we need to continue the same step. So you understood the condition, no? So after this, include these units in the remaining units and modify the new power demand according to the following equation. Say for example, we fixed some value. Again, that fixed value is also not satisfying the optimality condition. Again, after this, again we are checking that this conditions, no, this optimality condition. This also not satisfied. Again, you need to fix the things. Again, you need to find out the new demand. Again, we need to find out the new lambda. Again, we need to proceed the things. So, what is the what is the formula for finding the new lambda 1? That is demand PD new 1. Okay, there it is only PD new. So here it is PD new 1 is equal to PD new. So whatever the PD new, say for example, as I said, like 650 came now. So that PD there's here some example I said now. Here how much? 350. Here 1000. So 1000 minus 350 is nothing but 650. So that is PD news is 650. So PD new 1 is equal to 650 plus sum of fixed generation not satisfying the optimality condition. Say for example, not satisfying. Again, it is not satisfying. That unit, generation you need to fix, and again you need to add, and again you need to go to step 6. Step 6 again you need to continue the steps in whatever we have seen, that same thing. So in the algorithm wise, first what we need to do is step 1. What we need to do is you have to get the number of generating units. You have how many generating units? Say for example 3 or 4 or 5 or 10, 20, like that, 2 or 1, like that. We have to get the number of generating units, that is n. Here it is taken as small n. Capital N also you can take. It is not like mandatory, you should take only small n or capital N, like that. You can take any small n or capital N, not a problem. Next, demand, power demand, you need to get the values. So what is the power demand? PD. Next is that fuel cost function. From the fuel cost function only we need to segregate, that is AI PGI square plus BI PGI plus CI. That is the fuel cost function. That is the fuel cost function for, say for example, 3 generating units we have taken into account. For the 3 generating units, we need to get all the values of the fuel cost function. Next, maximum power generation limits, that is minimum and maximum power operating limits for 3 generating units. Say for example, first generating unit is 100 to 400, second generating units 152, some are 500, third generating units 52, some 200, like that. For 3 generating units you need to get the values of each units, generating unit. That is the step number 1. So what is the step number 2? So this is the main algorithm, that is for programming. Sometimes for problem also you can take, for problems what we are doing is we are taking directly this as a step number 1, compute. So here what is the step number 2? Compute lambda using the following equation. Lambda, you know how to derive the lambda. So easily you can derive the lambda, or otherwise you can remember. So lambda is equal to PD, power demand, plus summation I is equal to 1 to n BI divided by 2AI, the whole divided by summation I is equal to 1 to n 1 divided by 2AI. Say for example 3 generating units, 3 times you have to add. Summation means, say for example I is equal to 1 to 3. So B1 divided by 2A1 plus B2 divided by 2A2 plus B3 divided by 2A3. So here also 3 generated. So 1 divided by 2A1 plus 1 divided by 2A2 plus 1 divided by 2A3. That is the step number 2. So what is the step number 3? Compute PGI. Compute the PGI using this formula. Using the incremental cost characteristics, using this formula, that is PGI is equal to lambda minus BI divided by 2AI for I is equal to 1 to n. Okay, 1, 2, 3, 4 up to nth generating unit. So so whatever the generating units that is given in the problem, that much n you need to take. So 3 means, so you have to take like 3, I is equal to 3. So you have to say for example 3 generating units means you have to calculate 3 times by calculating the lambda, that is PG1, PG2 and PG3. Next, what is the next step? Step number 4. If the computed PGI value satisfies the operating limits or not. So you need to find out whether the computed PGI values are satisfied within the minimum and maximum operating limits. That is, whatever the PGI we are finding out, that should be within the minimum and maximum operating limits or not. That you need to calculate for 3 generating units. Say for example, 3 generating units, if you taken into account 3 times yearly, or otherwise like n means whatever n, say for example 10 also, 10 times you need to calculate whether it is satisfies the operating limits or not. Then if the optimum solution is obtained, okay, stop the step. Otherwise stop the procedure, stop the algorithm. generation satisfies. Generation also you found out, that is PGI 1, 2, 3 you found out, and it is within the operating limits. If it is satisfies, okay, just stop the step. That's all. We completed the whole procedure. Otherwise, go to the next step. If not satisfied, violates. If it is violates minimum operating limits or maximum operating limits, go to the next step. That is the step number 5. That is, if PGI violates the operating limits, PGI violates the operating limits, then fix the generation at its respective limits. That is, PGI is less than or equal to PGI minimum, then fix PGI is equal to PGI minimum. If PGI is greater than PGI maximum, then fix PGI is equal to PGI maximum. Next, what is the step number 6? Redistribute the remaining system load, that is PD. That is, you have to calculate new demand value. That is, PD new is equal to PD volt minus sum of fixed generation not satisfies the optimality limits. That is, not satisfies the operating limits. Whichever the generation not satisfies the operating limits, that you need to fix that you need to add, you need to sum up. Next, what is the step number 7? Step number 7 is compute the lambda new value. So lambda new value using the PD new value. So what is the lambda new value? Same thing. That is, lambda new is equal to PD new plus summation I is equal to 1 to n bi divided by 2ai, the whole divided by summation I is equal to 1 to n 1 divided by 2ai. Okay, so that you need to calculate. Okay, and similarly you have to calculate PGI new. Okay, so PGI new, this is not PD new, this is PDI new, PGI new. So PGI new, similarly, how to calculate PGI new? PGI new is equal to lambda new minus bi divided by 2ai. Lambda new is equal to, PGI new is equal to lambda new minus bi divided by 2ai for I is equal to 1 to 8. So now we have calculated lambda new and as well as PGI new. Next, step number 8. Step number 8 is optimality condition. This optimality condition already we know. This optimality condition. That is, we derived. Again, I am telling, that is dFi divided by dPi is equal to lambda nu na for PGI is less than or equal to PGI less than or equal to PGI maximum. If dFi divided by dPi is less than or equal to lambda nu na for PGI is equal to PGI maximum. If dFi divided by greater than or equal to lambda nu na for PGI is equal to PGI minimum. Next, if this condition is satisfied, then stop the procedure. That's all. Stop the procedure. Otherwise, release the generation and schedule the fixed generation to its minimum or maximum operating limits of those units not satisfies the optimality condition. Include these units in the remaining units and modify the new power demand. Okay, as I said, if this condition also not satisfied, again you need to fix the generation to its minimum or maximum operating limits. Again, you need to calculate the demand new value. So this demand new 1, demand new 1 is equal to PD new plus PD new means whatever we calculated before. PD new plus sum of fixed generation not satisfies the optimality condition. Again, again you need to go to the step number 7. Again you need to find out the lambda new, again PGI new. Again you need to verify this condition, optimality condition once again. If this condition satisfied, just stop it. Just find out, take down the generation, whatever the generation, because all the things are satisfied and all the minimum and maximum operating limits are satisfied. So no need to go proceed further. Just stop the procedure and find out the answer. That's all. Thank you, everyone.